Welcome to this demonstration of FireAnt, which is a plugin for Grasshopper that can calculate the fire resistance of beams and columns. In this video, I will show you how to use it and how it works. First up, when you have installed it, you get this folder up here, which contains these elements. Over here, there are 6 components, which are the ones that calculates the beams and the columns. And over here on the input side, there are 6 inputs that can help you adjust the calculations. So first up, we'll drag this one down. This is a component for a beam exposed to a standard fire, and using the reduced cross-section method, which is a simplified method for calculating fire resistance of beams and columns in wood. First up, you can see that this has an error message that doesn't work right away. That's because it needs some input before it works. The 2 input that it needs, it's center lines for the beams and columns, and a load to apply to the beams and columns. So we'll start by adding those. So we'll create a box that is 10 by 5 meters and 3 meters in height. And there we go. Then we'll take the top edges here, duplicate those, and then get these into Grasshopper. So there we go, 2 curves. Then we'll need to apply the beams that are crossing those 2 curves. You can do that by several different ways. You can also just draw them. Now I would like to make them so that I can show you different things. Oh, this one needs to be flipped. There we have it. So this will be the input curves for the this will be the input curves for the box for the calculations. And then we'll apply a load. Let's just make it 1. And for all the inputs, you can see by hovering over it what kind of input it is and what it needs. And this one needs a line load for the beam to support in kilonewtons per meter. So we'll just apply one load of 1 kilonewton per meter. And then it's very important that the amount of lines inputted to the component in a list has an equally long list of loads to apply, so that it corresponds with the first line being loaded with the first load. So now we have 11 loads and we have 11 lines. And now it works. So the outputs generated from this one is based on a catalog of different standard dimensions. So that would calculate the given fire scenario and then output the beam from the standard dimensions from the catalog, the smallest area, cross-section area, and that will be the one displayed over here with the width and the height. And then over here you can see the loading capacity of the given cross-section, and then the utilization rate compared to the load we are applying to it. And here if we highlight it, you can see that the output is shown over here in Grasshopper, by the way, and we can bake it just by right-clicking and then pressing bake as any other geometry. If we change the amount of lines, you can see that it follows and everything adjusts with it, as long as the list of lines and the list of loads are equally long. If you want to calculate for different loads or different lengths of lines, that's perfectly doable. You just have to add the different lines, still just the same length as the one with the loads. We can do this with the loads. Just make a random load, and let's take it up to 4 kilometers per meter. So now we get some random numbers. Oh, sorry, there, and this one should go over here. Right, 8 and 8. So now it's red, and that's because some of the components, or some of the lines in here with the given loads, just there's no profile with the given dimensions over here from the standard catalog with the given parameters for the fire that can support the load. So we can adjust that and then see what happens. To adjust some of these inputs, we can use the different standard pre-made templates, or you can just add a slider. So for instance, this one is the time of the fire, and the default value is 60 minutes. Now we can try one with 30 minutes and see if that changes anything. Oh, it did. So with a 30-minute fire and the rest and the default settings, you can see that there are everybody or all of the columns. There's a cross section available for that one to carry the specific load. And as you can see over here, it can calculate for different cross sections and apply them differently. That also functions very well. The settings you can adjust over here is the strength of the wood. That can be of different quality. And of course, if you lower the quality, then at a certain point, it will no longer be available to support the load. Secondly, there's the different. There's 3 different standard profiles. In this one, there's sawn, plain, and glue laminated. And as you can see, the default value is sawn. So if I apply this, nothing should change. If you change it to plain, then there's no cross sections in this standard catalog which can support the load. But for glue laminated, there is. You can see in sawn, there are some more and in here, these are here. The same goes for the different other settings you can apply, like the wood species, which determine the charring rate, which are here. And we'll of course need to do the one with the reduced cross section, because if we're using the strength reduction method, which are these ones, they have a different charring rate. We're going to apply this one here, and then maybe try to add a different species, and then you can see how it changes over here. Conifer was the default one, and then we can add it to laminated wood. Then there's the sides exposed. If it's a beam, usually you would have it exposed on the bottom and the 2 sides, but it could also be just the bottom. And if that is the case, the dimensions are smaller in the width. You can see width and the 2 times height, then it increases. And then lastly, there's the support conditions. For now, it is simply supported. Just need this. For now, it's simply supported. That is also the default setting. But you could make it cantilevered, or here is cantilevered, one in a fixed and one in a supported, or you can make it both in fixed, for instance, and then it also changes the it affects the calculation. if you're in a case where you have already a cross section that you want to verify rather than get one from the catalog, you can do that as well. If we take this one, make it a 200 times 200, you can just put it in the width of the profile and the height of the profile, and then it will do the calculation based on the given height and then apply that to all members. And if we increase this one, all the other things should increase up to a point where this profile just can't take this risk. So that's basically how it works. Then there's the same procedure. This is for a beam. For a column, it looks exactly the same and works in the same way. So does it with the parametric fire and the strength reduction method, which is the other variation of how to calculate your load bearing capacity. So that's basically how FireAnt works, and I hope this video was informational and will help you use this plugin.